This is lecture from the chapter 2 variable regression model, the problem of estimation. In this lecture again we will be discussing remaining numerical properties of OLS estimators. So continuing from the fifth property of OLS estimator, that is the mean value of residuals, that is mu I hat, is 0. Let's say that you have x and y variables and run a regression, and the regression equation is yi hat is equals to, again we are taking the same values as we did in our previous lecture, that is 11.9 minus 0.65 xi. So how do you get the residual? That is mu I hat is equals to yi minus yi hat. That is actual value minus estimated value. What we are saying, if you take the sum, that is summation of mu I hat, then it is equals to 0. And if the sum is 0, then the mean value, or you can say the mean of the residual, will also be 0. I am saying it again. If the sum, that is summation mu I hat, is equals to 0, then the mean of the residual will also be 0. We actually need to prove that mu I hat bar is equals to 0, that the mean value of residuals is 0. And here mu I hat bar is the mean value of residual. So how do we actually prove this? This comes from the OLS derivation. If you see that derivation we did in our last lecture, it is like this. We have partial derivative of summation mu I hat square over partial differential of beta 1 hat, and again partial differential with respect to beta 2. So these two derivations we actually take from the previous lecture. Now if you do this, in one of the steps we get this equation, that is minus 2 summation yi minus beta it's beta 1 hat minus beta 2 hat xi is equals to 0. Now taking this minus 2 on the right hand side, dividing it with taking this minus 2 over the right hand side of this equation. So we get summation yi minus beta 1 hat minus beta 2 hat xi is equals to 0. Now this term, that is beta 1 hat minus beta 2 hat xi, this is equals to yi hat. What is yi hat? It is equals to beta 1 hat plus beta 2 hat xi. So if we put yi hat over here instead of this beta 1 hat minus beta 2 hat xi, we get here summation yi minus yi hat is equals to 0. So this yi is the actual value and this yi hat is the estimated value. Now what we are going to prove is summation mu I hat is equals to 0 and mu I hat bar is equals to summation mu I hat, that is also 0. If we divide this by n, basically mu I hat bar is equals to summation of mu I hat over n, so it is equals to 0. And we prove that summation mu I hat bar is equals to 0. So actually what we have proved that mu I hat bar is equals to 0. It should happen always. So it should happen always. It happens always that mu I hat bar is equals to 0. So we can say that mean of residuals is 0, and it is always true that mean of the residuals is 0. This is all from this property. Now coming to the sixth property, that is the residuals mu I hat are uncorrelated with xi, that is summation mu I hat xi is equals to 0. Or you can say that the sum of the product of residuals mu I hat and the value of the explanatory variable, that is xi, is 0, which also means that mu I hat and xi are uncorrelated. It means that mu I hat and xi are uncorrelated and summation mu I hat xi is equals to 0. Now summation mu I hat xi is equals to 0. Product of the residuals mu I hat and xi, and if you sum them up you will get 0. This is what we need to prove. You have values of x and y, and you find the value of mu I hat if you have values of x and y, and you find the value of mu I hat, and in the, you can say mu I hat, and here in the last column xi mu I hat. You are multiplying actually these values x and mu I hat here, and if you add them all these values, then you will get 0. This proof is from the second least square normal equation. It is from second least squares normal equation, and the second least square normal equation is summation xi yi is equals to beta 1 hat summation xi plus beta 2 hat summation xi square. If I take all these terms to the left hand side, then summation xi yi minus beta 1 hat summation xi minus beta 2 hat summation xi square is equals to 0. Taking summation xi common, summation xi, now here yi, as we take summation xi common, so here in this expression yi minus beta 1 hat from this expression minus beta 2 hat xi, as there is xi square. So summation xi is common and xi comes here with beta 2 hat is equals to 0. Now this term beta 1 hat minus beta 2 hat xi, this is yi hat, so summation xi into yi minus yi hat is equals to 0. Now here yi minus yi hat is equals to mu I hat. So by adding mu I hat over here, that is yi minus yi hat, summation xi mu I hat is equals to 0. This is what we have proved, that summation xi mu I hat is equals to 0. Now we want to prove that correlation between xi and mu I hat is equals to 0. That Now we are going to prove that correlation between xi mu I hat is equals to 0. The formula for correlation is between variables a and b is equals to covariance AB. Correlation between two variables, that is a and b, is actually the covariance between two variables and then the standard deviation of a multiplied by standard deviation of b. If we want to prove that covariance is 0, then it is sufficient to prove that correlation is also 0. We can say that if covariance is 0, then we can say that correlation, it is C, is also 0. 0 covariance implies 0 correlation. So what is the covariance between mu I hat and xi? So covariance mu I hat xi here covariance AB is equals to 1 by n summation A minus A bar B minus B bar. This is the formula for covariance. That is equals to 1 by n summation AB minus B bar summation A by n minus A bar summation B plus A bar B bar, which is equals to summation AB by n minus B bar A bar minus A bar B bar plus A bar B bar. So these two terms cancelled out. Summation AB by n minus A bar B bar. So using this formula, if I want to calculate covariance between mu I hat and xi, that is so it is equal to summation mu I hat xi over n minus mu I hat bar xi bar. By using this formula, we can find the covariance between mu I hat and xi, that is summation mu I hat. We replace this value with a and xi with b over n minus same a bar is mu I hat bar and b bar is xi bar. We have already proved that summation mu I hat xi is 0 in the previous property. And we also proved that mu I hat bar is equals to 0. So from this formula, if summation mu I hat xi is 0 minus summation mu I hat bar, this term, if it is also 0, then the whole expression is equals to 0. From here we can say that if covariance is 0, then correlation between mu I hat xi is also 0. There is no relationship between residual and explanatory variable. They are uncorrelated, and hence we have proved this property as well. Now comes the seventh property, that is the residuals mu I hat are uncorrelated with the predicted yi. The residuals mu I hat are uncorrelated with the predicted yi, that is summation yi hat mu I hat is equals to 0. In the previous property, we proved that summation xi mu I hat is equals to 0. We have proved this one over here. This one. Now what we are trying to prove is that the sum of the product of yi hat and mu I hat is 0, and further it will prove that the correlation between yi hat and mu I hat is also 0. So what we are going to prove is summation mu I hat yi hat you can say that summation mu I hat, and here this yi hat, we know that this yi hat is equals to beta 1 hat plus beta 2 hat xi. So we put the value of yi hat over here, that is beta 1 hat plus beta 2 hat xi. Now beta 1 hat summation mu I hat plus beta 2 hat summation mu I hat xi. So if we rearrange this expression, we get this expression over here. So here summation mu I hat, that is the sum of residuals, and we have proved that sum of residual is 0 and this is also 0. Hence we have proved in the previous property that summation mu I hat xi is also 0. So you can say that summation mu I hat yi hat is equals to 0. And similarly, as in the last property, we proved that here if summation mu I hat yi hat is 0, then we can also say that correlation between mu I hat yi hat is also 0. It means that there is no correlation between estimated value and error. That's why correlation between mu I hat and yi hat is 0. That means that mu I hat and yi hat are uncorrelated. They are uncorrelated, means that correlation between mu I hat yi hat is 0. And also summation mu I hat yi hat is 0. Hence we have proved the last property as well.